This is a plane stress element, and we cut it diagonally. We can cut it with any angle. So we can cut it like if I pick up a line, you can cut it with any position you can cut. Okay, then you can make the free body diagram. So we cut it thus diagonally, make it half. Then we figure out that this sigma formula, this sigma, and also we figure out the value of this tau. And all of those things are the external load. You apply external, but sigma and tau we cannot see from outside. This is internal load inside the material, and we derive this formula. And after derive this formula, we got this equation. Right, this equation we found. One is this one, other one is tau. Okay. Now, if we look carefully to this equation, the value of sigma it depends on sigma x, sigma y, that means external load. And what is this portion? Actually, this portion is the average of sigma x and sigma y, right? Sigma x plus sigma y by 2. Then we took the difference of sigma x, sigma y divided by 2 into cos 2 phi plus tau xy into sine 2 phi. This is the formula. And if we look that right over here, you look right over here, sigma x is tension. That's why sigma is positive. And look over here, sigma y also positive because it is also tension. If sigma x, I put like that, that means that value will be negative. I put y, sigma y like that, then sigma y will be negative. And the tau, this tau always will look right over here, right this corner. So this tau xy moving upward, and other side, opposite side moving downward. What he is doing is try to move this object, try to rotate this object anti-clockwise. So anti-clockwise tau is positive. So what we found, if sigma x is tension, then positive. If this is tension. Similarly, sigma y equal to positive if it is tension. And tau xy is positive if it is try to rotate the object in anti-clockwise direction. So this sign convention we have to remember. And is this phi angle? We took this on phi, right? But this sigma with x-axis, it make angle phi. And this phi will measure anti-clockwise. So phi, angle phi is positive if we measured anti-clockwise. Okay. So in this formula, we have to meet this sign convention. Why? I might put like sigma x. Right over here, I put sigma x, sigma y, but I might put a plane stress element like that. So I'm showing this is arrow, this is downward. So this will be out, this will be operation. And right over here, I'm saying shear stress going down. So right over here will be also going up, right? Because this will be opposite of this one. Both are will be same going up. So right over here, it will be, shear stress is head to head, tail to tail. Both arrow head will be together, both tail will be together. Now, if I say that this is 60, for example, I am saying This one is 80. And tau xy, we don't know how much. Say tau xy, I'm saying this is 10. This is obviously this both will be same 10. So in that case, sigma x will be how much? Sigma x equal to positive 60. If I put unit megapascal, it will be positive 60 megapascal. Sigma y is downward, right? You'll say sigma y equal to this sigma y equal to minus 80 megapascal. What about the tau? You always count tau with respect to x, right over here. So you see this tau try to rotate clockwise, but right over here try to rotate anti-clockwise. So tau xy will be minus 10. Right over here we'll say, when you write down that what value is given, you'll say tau xy equal to minus 10. That will be okay. Now you see this sigma value and this tau value is vary on angle phi. This angle might be 10 degree, 20 degree, you can cut to 70 degree, 90 degree. Then each time you'll get different value of tau. Okay. So for which value of tau and the sigma, the material will change. Number one thing, if you cut this angle phi equal to 10 degree, phi equal to, you cut it by 20 degree, then you make 30 degree or 35, 40, and we go, let's say last, we go 85 degree. Then each time you'll get one value of sigma and tau. And if you put all the value, then one time you will see for a certain angle, that means certain angle of phi, that means angle of plane, the plane at which you are cutting the object. That plane, value of sigma coming maximum. Say at 30 degree angle, you are getting value of sigma. For example, you are getting 120, but tau you are getting 0. Similarly, at one stage, say angle 70, you get sigma equal to say 60. Sigma 60 and tau, you will get maximum, say maximum you got 9. So for the same angle phi, you will get value of sigma, value of tau. You start phi equal to 5 degree. Then you start phi equal to 10 degree, you will get value of sigma, value of tau. And both each case, you will get different value, different sigma. In one stage, you will see you are getting value of sigma, highest value, but your tau in that plane is 0. Similarly, at the angle, you will get phi tau maximum, and sigma you will get only this component. That means you get only average value. So we need to figure out that which plane it is giving maximum value of tau and maximum value of sigma. So this formula is needed. If I say figure out the plane stress or stress sigma and tau at a cutting plane 30 degree. Then you put phi equal to 30, you get sigma and tau. If I say angle equal to 60, you put that angle, you get the value. That means you have to know the angle phi. Then you can calculate. Now, but you don't know for which value of phi this sigma will be maximum. And for which value of the tau, phi, tau will be maximum. That we need to, you cannot do iteration. Each time you put, make a spreadsheet, you can figure out, but mathematically we need to have a formula that for which value sigma maximum and tau maximum. So if for a cutting angle, say cutting angle phi equal to, I'm just saying phi 9. Like you put phi equal to 10 degree, 5 degree, 18 degree, then 26, 22. And you cutting gradually increasing the angle. And at 9, phi 1, phi 2, phi 3, at 9, you are getting sigma maximum. Say sigma maximum 120 megapascal. This is value of sigma. But for same angle, you put it over here, you will get tau equal to 0. Then this plane is called maximum principal plane, because at this point you are getting maximum normal stress sigma. Similarly, for same angle, you might get sigma equal to negative or minimum value, so get minimum 60 and also tau equal to 0. So for a plane where sigma value coming maximum and minimum, but tau value equal to 0, that plane is called principal plane. So we need to know a formula for principal plane, angle phi, and also we need to know, figure out the formula. So you see, if for phi 9, sigma getting maximum and minimum, but both case tau 0, then this phi, instead of phi 9, we'll call it phi p. That means this is my principal plane. Similarly, for a angle phi, you will get tau value 1 time max. For same angle, 1 time max, and you will get tau equal to 1 time minimum. And sigma, you will get only sigma average, this one. Then that plane, we will call it phi s. That means shear plane. So if you know this formula, phi s and phi p, then you can easily figure out the angle. You have the angle, then you put just right over here. These two equations, this equation and this equation, you'll get phi and you'll get value of tau. So we need to have a formula for phi s and phi p. Who can tell me how we can figure out the maximum value or minimum value of sigma for angle phi? Anyone? Anyone can tell me? No? Only 15 students join. Okay. What is the sigma? If I say sigma equal to y, okay, and these are constant, right? This is not variable. I'm saying C1 plus C2 plus x. Tau xy is the constant, right? So I'm saying C2 into x. Phi, sin phi, I'm saying x. The function of phi is the x. So if you differentiate this equation, if you put dy by dx equal to 0, you put differentiate this one, put this equal to 0. From there, you figure out value of x. So you get the maximum phi or the maximum value of sigma. If we differentiate, what is the differentiation actually? Say along this axis y, this is x. You have a equation, you have a graph going like that. What does it mean? Right over here, slope of the curve is increasing. Right over here, downward decreasing. Right? What about right over here? What is the slope? When it got maximum, slope equal to 0. That means dy by dx equal to 0. Right over here, it is equal to 0. So this is giving you maximum value. So when for you have a function like you have y equal to x plus 3x cube. So this is not straight line. This will be a curve. So how we'll figure out maximum where y value will be maximum, y value will be minimum. So right here, y value will be minimum, over here maximum, also over here maximum. To get the maximum value, we figure out this value. dy by dx equal to 0. Then from that we figure out value of x. That value of x, say x right over here, this is x1, say this is x2. These x1, x2 you put over here, you will get y1, y2. So that we'll do right over here. Similarly, we'll do for tau. This one actually you learn from your mathematics, that why we do the differentiation. Okay, so what is the principal stress and principal plane? Sometimes we put this short question in the exam. It's saying the plane in the plane stress element. Plane in the plane stress element, I should put a comma over here. Plane stress element where shear stress 0 and normal stress maximum or minimum, then it is called principal plane. So a plane, cutting plane at an angle, certain angle, where you are getting sigma value maximum or minimum, but phi tau value 0, that plane is called principal plane. And the corresponding stresses is known as principal stress. Corresponding stress, that means phi sigma 1, sigma 2 is called principal stress. Maximum value of normal stress is known as major principal stress. You might get two value of sigma, both case tau 0, tau sigma max and sigma minimum. So max value is called major principal stress and the minimum value is called minor principal stress. At principal plane, normal stress, sigma max, minimum or maximum, but shear stress is 0. That is the definition of principal stress and principal plane. Second one, maximum shear plane. Similarly, maximum shear plane for an angle, you will get tau value maximum or tau value minimum. We say the plane in the plane stress element where the shear stress maximum is known as maximum shear. So tau value, or you can say maximum and minimum shear plane. In max shear plane, tau is always maximum and minimum. You get two equal value of the tau. Say one you might get minus 80, other one you get plus 80. So plus 80 is the maximum value and minus 80 will be minimum value. And in that angle, right over here, you get sigma, what happened right over here. Let me pick up line. You get sigma max, one value, right? One value. Both will not be same, different. And right over here, you get sigma minimum. But what is the value of the tau? Tau 0. But right over here, you get tau max. So you get one value. I'm saying this is tau max value. So you get 100. So what will be the tau minimum value? I'm saying this is max, tau max. Similarly, you get other value, tau minimum. Tau minimum, you get minus 100. But what will the value of sigma? Right over here, sigma is not 0. Right over here, your sigma will be sigma average. That means you will get sigma x plus sigma y divided by 2. This will be your sigma. That is called sigma average. So it is coming from where? If you look to our formula we have right over here. This component you will get at shear plane. This is the you will get sigma. Okay. So how we can figure out the value of sigma, value of phi s, and value of phi p? We need to figure out maximum principal plane angle, phi p. And we need to figure out phi Yes. Shear. If you know these two values, you put in the equation, you get the sigma max, sigma minimum, and tau. Right over, you will get sigma tau max minimum. You put in this one, you will get, again, I will explain again. You get tau max, one value, comma, you get other value, tau minimum. And also you get sigma average. Average is equal to sigma x plus sigma y divided by 2. And when you use the phi p equation, you will get sigma 1. That means maximum principal stress. You will get sigma 2. Minimum principal stress, but both case you will get tau equal to 0. There is no shear stress. Because a crack might be developed due to the maximum principal stress or might be for maximum shear stress. So you need to take both one, shear stress and also with maximum principal stress. Now, right over here, you see I put some trigonometry formula. Say this is a triangle. So length of this, say I have this one I know. From here, how I can figure out value of sine and cos from this triangle? Easily you can figure out. So how? This is say 2 phi angle. The tan equal to perpendicular by base. So tau xy, this will be perpendicular and this will be base. So you figure out the hypotenuse. Then what are you getting? You're getting a square. If this is a root over a square plus b square, right? And for root over there will be plus minus sign. So you got the hypotenuse this. Tau x square plus base whole square, then root over. So in a triangle, you got the all three arms. Now easily figure out the cos phi. Cos phi will be base by hypotenuse. So this is my base divided by hypotenuse. Sin phi perpendicular by hypotenuse. So you can easily figure out. Okay. So this is the tricks. I just put it over here. Now we need to figure out that what is the value of phi p formula. We need to figure out. And after we derive, we'll show you how to derive. We'll get this one. This formula will get tan 2 phi p equal to 2 tau xy sigma x minus sigma y. And you need to derive this equation. But when you solve problem, you need to remember this equation. Say, for example, you getting tan 2 phi. For example, you getting tan 2 phi p equal to 1. Then how will you figure out the angle phi p? Tan 2 phi p equal to 1, right? So I can say tan 2 phi p equal to tan 45, right? I can easily say tan 45. Then 2 phi p will be how much? Then this will be phi p. 2 phi p equal to 45 degree. Then you figure out the phi. Phi p equal to 22.5, right? And Alamin, you are roll 82. You are in the computer?
Yes, sir.
You have calculator with you?
No, sir. Sorry.
Oh, okay. Tell me, tan 45 equal to 1, right?
Yes, sir.
Yes, sir.
If I add 90 degree, tan 135 will be how much? 45 plus 90. Then what do you get? 45 plus 90, you will get 135, right?
Yes, sir.
Tan 135 equal to how much? Put your calculator.
Okay, so just a second, sir.
Okay. Okay, tan 45 is just right over here. I'm saying, say tan theta
Sir, -1, I think.
-1. At 180 plus 45, that will be 225, right? What is 225 equal to how much? You see plus 1. Tan 245, tan 225
Yes, sir, +1.
plus 1. So what are you getting? Say after I solve, I am getting tan 25 e, I am getting 1, right? So I am saying if I get 1, that means this equal to tan 45 degree. I can say because tan 45 equal to 1. So how much the phi? Phi will be, then you write down 2 phi p equal to 45, phi p equal to 25.5, right? Okay. Now,
Sir, yes, sir.
now you write down that tan 2 phi equal to 1, right? Instead of tan 45, you write down 225. So you are wrong or right? Tan 225, because tan 225 also equal to 1. What does it mean? Both right, right? So from here, if you do
Yes, sir.
phi, you say 2 phi equal to 225. So phi will be 11.5, right? You will say 111.25. I'm sorry, 11.5. 111.5. 22.5 plus 9. So what you see over here? For the same tan angle, you are getting 2 phi p. Say right over here, one we are getting 22.5. That means 2 phi p equal to 45 you are getting. And 2 phi p equal to you are getting angle 225. So this phi p angle, if you substitute right over here, how many sigma you will get? You get 2 sigma, 1 sigma 1, 1 sigma 2. And you will see one value giving maximum, other one giving minimum. And those two angles, if you put in this equation, you'll see tau coming automatically 0. Okay, if it's not coming 0, that means you did some mistake. Similarly, right over here, there is another way we can figure out this sigma 1, sigma 2. I'll show you later on. Similarly, we need to figure out the tan phi s. So this is the formula for tan phi s. So tan phi s, similarly, you get how many value of phi? Right over here, you will get 2 value of phi s. And these 2 value, if we put right over here, say you got right over here, you got 2 phi s. Say 2 phi s, you got 30. What will be the other one? Just you need to add 180. And other one will be 2 phi s equal to 180. That means 230 plus 180. You get 210 degree. Why 180? Tan theta equal to tan theta. Okay. Again, tan 180 plus theta will be how much? Tan 180 plus theta. It's the economic. 180 plus theta. This also give you theta. That's why for same angle, tan always give you 2 value. One is maximum value, other one is the minimum value. Now these 2 angle you put over here, you get tau 1 and you get tau. And you will see both value is same. One is coming with plus sign, other one coming with minus sign. And both case, you get sigma equal to only this term. And you will see this term coming automatically. Okay. Now, so you see, I just show you that what will be our two formula. Number one, phi p, we get this formula. But I don't show you how to derive this formula. Other one, 2 phi s equal to this formula. So now we need to check. We need to see that how these two formula is coming. Okay. So what do? We take the original formula. I call it mother formula. This is our mother formula. Right over here, all the formula I put right over here. This is mother formula for principal stress, and this one for shear stress. And from the differentiation, we can figure out the angle phi s and also angle phi. Then we have other formula. Without say you don't need this formula. Okay, example. By using these three formula, fourth formula, you can figure out phi 1. That means phi s, phi p, figure out. Then you can figure out sigma max, sigma minimum, and the tau. Second case, you figure out the phi s, you will get tau maximum, tau minimum, and sigma. In that case, sigma will be average. By using these three formula. What is the first step? First step, from here you figure out tan phi p. You will get two angles. These two angles you put over here on time. The first angle you put over here, you put over here. When you putting in the tau equation, you get tau 0. When putting in the sigma equation, you get some value of sigma. Sometimes you might get 1, 0, possible. And you put other angle, you will get sigma 1 value. But both cases, tau has to be 0. This is the principal plane. Now we need to work with the shear plane. For shear plane, if you use this formula, you will get value of phi s. Two angle you will get. For both angle, it's a phi s 1. Say you got phi s 1 equal to 20 degree. You put over here. So you will get, you see the value you will get is the equivalent to average. If sigma x 40 and sigma y 60, then the average will be 50. So you will get the average value. And when you put the angle in the tau equation, you will get value of tau max or tau min. So you put phi s equal to 20. What will be the other angle? 2 phi s equal to 20. If you put this one, that 2 phi s equal to 20. Then other value will be how much? 180 plus 20. That we need to add 180. So 180 means 200. When you put the 200, then you see sigma value is not changing. Sigma value is coming the same. And tau value, you will get the same magnitude, but opposite side. Okay. Now, we need to say that how we can derive these two equations. Okay. Now that we will check it with math done. So far, any question? Any
Sir,
question?
from this we can conclude that we are getting two formulas from tan function.
Two formula from
Tan functions.
Two formula and
Like you
function.
like you told that we for 20 degree angle we can again get 180 plus
yes,
20
yes.
again.
What happened? Tan value always give you two value. So if you ignore the other one, for example, 2 tan 2 phi equal to tan 2 phi equal to 1. So you then instead of 1 you write down tan 45. So tan out. So you will get 2 phi p equal to 45, right? And your other friend write down tan 2 phi equal to 1 equal to tan 225. So both you are right, right? So
Yes, sir.
if you choose only one angle, then that means you are missing something. So you need to check with both angles. So you have two value of phi. That means twice you need to put that angle in the equation. You got my answer now? Clear?
Yes, sir. Yes, sir. It's clear.
That you will do. Right now, I will show you that how we can get that formula for tan 2 phi p and tan 2 phi s, or how we can derive. That I will show you how. It's easy. Just I already give you the introduction, so this will be easier for you. Maximum derivation of right last class. That means last week we show you that how to we derive this equation. Okay, this is our mother formula for sigma. This is our mother formula for tau. Okay, now we'll show you how we can figure out the principal stress. We use the same mother formula. I just put the free body that you realize that coming from there. So this is our mother formula. You see, you have no chance to vary this sigma x, sigma y. This is external load, is constant, it's already given. So this value, we cannot change it, right? Only cos 2 phi and sin 2 phi is the changeable value or variable value. So if I figure out that for which phi, sigma will be maximum or minimum, then what I'll do, I'll figure out the slope, dy by dx. Because for a maximum minimum value, when it is come, when a function slope getting maximum, then right over here it will get maximum value. And right over here slope 0, you'll get the minimum value. So if you figure out, that's why in the tan equation we are getting 2 value after differentiation. We'll show you. So now we differentiate this one. Delta d sigma by d phi. So this value is constant, right? There is no phi, differentiation will be 0. So you have this term now. So this term I put half into, I write down this way. Then derivative of cos 2 phi, you will have minus 2 sin phi. Then tau xy, derivative of 2 cos phi, sin phi will be 2 cos phi, cos 2 phi. This derivative equal to 0. I can put it, right? Then if you simplify the equation, 2 will be out from both sides, this number 2. Okay. Then if from here, you just rearrange the equation, you figure out the tan 2 phi. If you figure out the tan 2 phi, you get this. So what does it mean? Right now, I will not say this is phi. I'll say this is principal plane. Because I already figure out what is the stress maximum minimum. I apply that condition. So right now, this angle, I call it principal angle, where sigma will be maximum and sigma will be minimum. Now, mathematically, you will get certain value, right? Say you will get 1.11. If you use your calculator, you can figure out the value of tan phi. And that angle, you put over here. Say, for example, you get tan 2 phi equal to 42 degrees. You just put it in the equation in the calculator, you'll get value the sigma. So one stage, you see, I show you over here. You see tan 60 degree. Say after this formula, you get right hand side 1.73. So this equal to tan 60, the right down. So tan 2 phi equal to 60 degree. Again, tan 240, that means 60 plus 180 is coming the same value. So what does it mean? One time you can say tan phi s equal to 60 degree, and other time you can say equal to 240 degree. And both value you can put it directly. So by calculator, you got sigma 1 and sigma 2, right? But this is your condition of maximum principal plane where tau 0. Prove it without putting the number. How you can prove it? Or you show me that after putting this condition, I'll get sigma 1, sigma 2 from the equation. without putting number. You do it mathematically. You already studied second year, fourth year, first year math. So you have to prove it mathematically. So how you can prove it mathematically? I have the value of tan 2 phi p, but in the equation I have cos 2 phi and sin 2 phi. So how we can figure out this value? You can say, sir, I can divide both sides by cos 2 phi. Over here will be sin tan, but over here will be 1 by cos 2 phi. So you cannot divide. So what need to do? In the equation, I have cos 2 phi p, right over here sin 2 phi. I know the tan value right over here. From this tan value, I need to figure out the value of cos 2 phi, this one. And I need to figure out sin 2 phi. Their value, if I put in the mother equation 1, then I can figure out the sigma 1 sigma. So let's do it. Just use a tricks. It seems like it's complex, it's not the complex. Use your trigonometry. Just this is tan value. You draw an angle, triangle. So say this is tan phi p angle. So this will be base, this will be perpendicular, right? So tan equal to perpendicular by base. So this will be base tan xy. This is my, I'm sorry, perpendicular. This is my base. Then figure out the hypotenuse. From there, you figure out cos 2 phi. Cos 2 phi p equal to base by hypotenuse. Now hypotenuse, there is a plus minus sign. I am keeping the plus. Okay. Similarly, I figure out sin 2 phi perpendicular by base. So now you see, now I have sin 2 phi p value, cos 2 phi p. These two value, I will put this equation in mother equation 1. Then I see how look like the sigma. And you can see it is coming interesting, very interesting. If we put there to this is my cos value, this is my sin value, this is my mother formula, this is mother formula share formula, right? Both equation I'll put this value. So you see, at first you put in this equation. So this is my first term, it remains as it. This is the second term, this one, then multiply by cos 2 phi p. So where is cos 2 phi p? This value, a little bit bigger value, right? The whole value, I put it over here. Then what do we have? Tau xy. Tau xy I put over here. Value of sine I put over here. Little bit higher value. Okay. Now you see, I just rearrange. This term remains the same. And right over here, this term and this term is coming whole square. Right? And in the bottom, we'll have this term. Similarly, for this term, this tau xy, tau xy square. Right over a plus minus and this term. Right? Now you see this plus minus multiply with the plus minus. That means right over here there will be plus minus sign. Right? Right over here will be plus minus sign. Now this sigma, see this plus minus, I just put it over here. This program, it don't allow me to put like that, like plus immediately below minus sign. So just I put minus sign right over here. This is minus, just after bracket. This is minus sign, this is plus sign. And if you look the bottom, the denominator is same, right? If this is x, this is also x. So I just add it. That means a by x plus b by x, right? You are getting same. So now what are you getting? This is root over x at the top, only x. So if you simplify, this one you can write down x and bottom is root over x. So you can say at the top I have root over x into root over x, and in the bottom I have only root over x. So this root over x will be out. So you have only root over x. So what are you getting? This is the sigma maximum. With plus sign, you get one value. With the minus, you get one value. So what do you see from here? So you see, this is my sigma 1, this is my sigma 2. So what is the benefit of this equation? You see, is this equation, without looking to the angle, you can directly figure out this value, right? That sigma 1 and sigma 2, there is no tan phi cos phi. Say, for example, you will get sigma 1 equal to 110. And sigma 2, you will get say 20 megapascal. But you figure out this one without using angle. You using direct the maximum formula, right? How did you know that this is for say phi s? Say for example, your phi 2 phi s or 2 phi p, you got two angles. One is 22.5 degree. Other one, you get 11.5 degree. Just for example, two values. Now, sigma 1 you get using this formula. How did you know this is for angle 225 or this is for angle 111.5? How do you know? You cannot tell unless you put both angle in this equation, in mother equation. Both angle, if you put in the mother equation, say you putting 111.5, you getting sigma 2 equal to 20. That means obviously 20 degree megapascal working in that angle. That means you need to again use, you have to use in that equation. And when sigma equal to 22.5, then you get 110. That means 110 you are getting for angle 22.5. So what I'm saying, if you use directly this formula, you have little bit a problem that you don't know that this is value is happening for which angle. So what I feel that you figure out, start with this equation, you figure out two angles. These two angles you put in the mother equation. This equation and this equation. Now for cross checking, you just use this equation. This one and this one. If both value is not coming same, that means you are making some mistake. And if it is coming same, that means you are happy. Okay, so this phi p angle right over here, or this phi p, what is our phi p angle? Right over here. This phi p angle, we just figure out the value of sigma 1, sigma 2. And we know at that angle, tau will be 0. Prove it mathematically. How can prove it? Same way you can prove it. How? We know the value of cos 2 phi, value of sin 2 phi. These two angles we put in this equation. And we try to see what happens. You put in this equation, you see, at first you put, we figure out the sigma, right? Right over here, or principal plane. This is your mother equation. We know tan equation. From the tan equation, you can substitute this formula. You can substitute these two formula. You can put in this equation, it will give you the same result. You get the 0. But if you have easiest way, you can put it. How? You see, tan 2 phi equal to this much, right? I can break up this one, sine by cos. Then you multiply. So half into sigma x, sigma y, sine 2 phi equal to tau xy into cos 2 phi. Now, you put over here, then what do you get? This is this equal to this, right? You get over here, you see, the same value, but over here is a minus. So I keep the minus sign and I substitute this value. This value equal to tau xy cos phi. So tau xy minus cos phi plus tau xy cos phi. So after simplify, you get it automatically. Okay. So what is the summary? All principal plane, shear stress always 0. Only remain two principal stress, sigma 1, sigma 2, and angle of principal plane phi. Okay. For example, phi p, you get 30 degree. What will be the other phi p? Without calculation, you can say just add 180 degree, 210. Then these two angles, you put in this equation one time, in this equation one time. If you get tau 0, you get value of sigma. Then you put this one again. You will get sigma 2 and you get tau equal to 0. Okay. So this one, you are getting for principal plane. Because any way you cut, always there will be two stress, one normal stress and one shear stress. And what is the shear stress? You cut at a plane where shear stress will be maximum and sigma will be sigma average. How we can prove it? What is our mother equation for shear stress? You see, this is our mother equation for shear stress. So this equation, if I derive like that, d, I say, where is my tau? D tau by d, I'll say d phi. D phi equal to 0. If I apply this condition to mother equation of tau, we will get the phi. Okay, and let's see. It's very simple derivation of shear stress. So you see, this is our mother formula. Okay, so what we did, d tau by d phi we figure out. So this value remains same, sine 2 phi, 2 into cos 2 phi. Similarly over here, for cos 2 phi we get 2 minus sine 2 phi. So minus is coming over here. This equal to 0. Then you simplify. After simplify, you get cos 2 phi just taking below of sine 2 phi. You get this one. So after simplify, you get this one. Okay. So tan 2 phi is equal to minus this one. Similarly, from this condition, tan phi 2 condition, you can figure out value of cos phi, value of sin phi. Now, this is tan theta equal to this one. And this is say theta 2 equal to this one. If you multiply these two values, what do you get? Say tan 2 phi s phi, I say p star tan 2 phi s. If you multiply, what do you get in the formula? Anyone? If these two multiply, what do you get?
Sir, 1.
1 minus 1. You see, there is a minus sign over here.
Minus 1.
Minus 1. So when tan m1 plus m2 equal to minus 1, what does it mean? That means difference of angle, they are perpendicular to each other. That means principal plane and the shear plane, angle between these two planes is 90 degrees. Because when two lines is perpendicular to each other, then slope m1 into m2 equal to minus 1. you know from the geometry. Okay. Anyway, we figure out the condition that 2 phi s equal to this. Now from here we'll figure out the sigma and tau. How we can figure out? From applying this condition and the triangular, we figure out cos 2 phi, sin 2 phi. So we figure out this cos phi and sin phi, right? Now, what is our mother equation of tau? This one. You put over here. You can see what we get. You put over here, we get this one into this one. What is this one? This find with. Then plus tau xy cos phi. You put the tau xy into cos phi. Similar situation you are getting. How? This one multiply with this one. So this one will be whole square, right? And this tau multiply with this tau. So we get whole square. And denominator is the same. This is x, this is x. So you can say a by x, this is b by x. So you can say x, a plus b by x. So this is coming like a by x plus b by x. What will the value? Equal to, you are getting a plus b divided by x. That will get, right? And next line, if you look carefully, in the top, what you are getting, in the top you have x, in the bottom you have root over x. So this result you will get equal to root over x. So you see right over here. So this is say b square, this is say a square. So at the top, you're getting a square plus b square. In the bottom, root over a square plus b square. So root over x will cut, you will get only one term. So this is your tau max minimum. You see, with plus sign, you'll get one value, with minus sign, you'll get one value. So that means same value, just coming with opposite sign. Now, these two values, these angle sine and cos, we are putting mother equation of sigma. And instead of putting the value of cos phi sin phi, I feel that this is more easier. Tan 2 phi s equal to this, right? And tan phi s equal to cos sin by cos. Then you just simplify. So what we're getting from here, tau xy into sin 2 phi s equal to this one into this one, into cos. So we get this. Now, this tau xy value, you put over here. You see there is a minus sign. So you put this value over here, then or I rearrange it. This one I bring in the left side. So I get this one plus this one equal to 0. That means when you put in the condition, then summation of this term is coming 0. So what is remaining only? Remaining only sigma average. Okay. So how many formula you have? Mother formula is the same. One equation mother formula. Okay. And this is the angle for shear plane. So it says at maximum shear plane, principal stress is equal to average of sigma x, sigma y. Algebraic summation divided by 2. Shear stress tau 1 and tau 2 will remain. One will be maximum, other one will be minimum. Now both will have same sign. And angle of shear plane is 2 phi s. And sigma 1, sigma 2 is coming, sigma average, and tau, you one time take positive value, other time you take negative value. This is the I summarize for maximum shear plane. Similarly, in the right side, the same problem I just summarized over here, that when you get apply principal plane angle, then our mother equation is the same, two equation, right? You get the same mother equation is this two. So you can could you hold on 1 second, please? Just a second. Hello. Walaikum salam. কোথা থেকে? ওটা টাইলস থেকে। ওই আপনি বলে দিয়েছেন না ঠিকানাটা? পুলিশ লাইনের মাথা পূবের মাথায় আসছেন? এখন ডান দিকে যান। ডান দিকে যা সরকার বাড়ির কাছে যাবেন। হ্যাঁ, আপনি বলবেন দেখবেন যে ওই বাম পাশে ৪ তলা একটা বিল্ডিং আছে সাদা রঙের। হ্যাঁ? আচ্ছা ডান পাশে দেখবেন যে একটা টিনের ঘরের আছে মানে সেমি পাকা বিল্ডিং দেখবেন বাউন্ডারি ওয়াল রং করতেছে গেটটা দেখবেন যে নীল কালারের ওখানে যায় আমার কল দেন আর ডান পাশে তাকালেই হবে হ্যাঁ আচ্ছা ওকে ওকে সরি so you see when you use the condition of principal plane then you will get this condition. This is for sigma, this is sigma 1, this is sigma 2, and this is W of tau. Okay. So our class will be continue. Any question? Do you have any question? Anyone?
No, sir.
No? Okay. Our class will be until 12:10, right? So just take a 5-minute break. Come back at 10:50. Then we'll start the rest of the topics. Okay. Okay, I am back. Are you there?
Yes, sir.
Okay, so let's summarize. You might be a little bit confused because we derive actually, you see, three equation or three derivation is over here. Number one, what we did, we derived the mother equation for sigma and for tau. That is, we derive how we derive. We just make a free body. We make the trace element up, right? The rectangular element. We cut it diagonally. Then we just take the one part and we figure out that at the cutting plane, angle phi, always there will be two stress, on normal stress, on shear stress. That's why we did. We did sigma outward and tau we did rotating anticlockwise, right? Now you can do any direction. You can say why we did upward sigma. What will happen? I put like that. Or what will tau you consider this? You will be right. Only what will be difference in the equation there will be negative sign. Okay, but for conveniently we put this tau anticlockwise because our mother free body. If you look in our mother free body, this side tau was anticlockwise, rotating along this direction and this direction. So that's why we did like that. If it's similar with the main body. Now we need to figure out the value of sigma and value of tau. So how we did? We make summation of force along x-axis, summation of force along y-axis. We get two equations. Both equation it has tau and sigma. Then we just solve equation by multiply sine theta cos theta. We take summation, one time we take subtract. Then we get the value of tau and sigma. Right. This one our first equation, summation of force along x-axis. This one our second equation, summation of force along y-axis. Then any way you can solve it. I feel this is the most simplest one, easiest one to figure out the value of sigma. Then we similarly we multiply with cos phi, equation 2, subtract sin phi by multiply by equation 1, we get value of tau. Now what I did over here, for making simplification, we use some trigonometric formula. Like this formula we use, then we use sine 2 theta equal to sine theta cos theta. That one also we use to derive this formula. Okay. And other thing you need to remember that we are making summation of force, not the stress. So how we get the force? Stress into area. Now in the free body, we're just showing that no, we are not showing thickness, right? Del y is the distance along y-axis. You can hear me?
Yes, sir.
Okay, I was disconnected. So what I'm saying that we need to make summation of force, not the stress. But in the free body, we have stress. So how will get the force? You just multiply by the area. So if this is dimension along x-axis and y-axis. So what is the dimension along z-axis is dx. So if I show you the thickness, although I show you several times, right? That again I can show you the thickness, this one. So this free body will be actually right over here. They need to be right like that, right? So for bottom one, it's a tau xy working actually in the surface. So this surface area will be length into width. Length is dx, width will be dz. And for this one, we figure out the length is ds. And we apply cos phi sin phi. We figure out some relationship with ds and dy. Similarly, dx into ds by dx by ds by sine phi. Okay, then we just use those two formulas, and then we simplify. So this is our mother equation. What is the benefit of mother equation? If you know the angle phi, you can figure out the sigma 1, sigma 2. Now, why we need to derive second equation to phi to figure out value of 2 phi p? Why you need it? 2 phi p, right? Equal to what? It not allow me to draw a hot side. Okay, you need to figure out this one. Then you need to figure out 2 phi s equal to what, right? Because we are not sure. We can solve it without these two equations. Then we need to solve too many times. You start from 0 degree, 1 degree, 2 degree, 3 degree, until go to the 90 degree, right? But instead, if we have the formula, then we can easily you can shoot the bar. Okay, you figure out the formula, you know the angle, use the mother equation. So hello. Hello, are you there? Sorry,
Yes, sir.
somebody delivering is something, but he went to wrong house. Anyway, so what I'm saying, now we need to know that where, for which angle tau will be maximum, sigma will be maximum. That's why we need a formula. But it is easy. We know over here variable only phi. So differentiate this angle, this equation in terms of phi, and second equation also in terms of phi. Then you figure out the condition in terms of tan phi. Because, and now you might say, why you figure out in terms of tan phi? This is the simplest one. Okay, that's why we did in terms of tan phi. Hello. আচ্ছা আমি ক্লাসে আছি, পরে কথা বলছি, তুমি নামাই নাও, ঠিক আছে? So at first we figure out the principal stress, sigma 1, sigma 2. So how we did? Right over here in the formula. We took the mother equation right over here. That's summarized. So we have to do on time for sigma, next time for tau. That we did. We take the mother equation, we make the derivative equal to 0, then simplify, we get tan phi. Right? Now we can stop it over here. That without figure out the bigger formula, we can figure out the tan phi angle. Two angle from here. You put that angle in this equation and tau equation, you get value of tau and sigma. It's possible. Okay, but sometimes you need to know, just cross check that you are doing the right thing or bad thing. So how we did, without derivating the number, we is called analytical formula. Analytically, you are proving what is the equation of sigma 1 and sigma 2. So we have tan phi p. From here we figure out cos 2 phi and sin 2 phi. Okay. Then this cos 2 phi sin 2 phi, we just substitute right over here. Then we get the value of, after substitute, you need to a little bit simplify. Then you get sigma 1, sigma 2. And sometimes we put the condition that derive principal stress formula, sigma 1, sigma 2, from the following equation. Okay. And similarly, those conditions we put in the shear stress formula and we get shear stress 0. So this is one condition. Next condition, that how we know the angle of shear stress. So that equation is right over here. Shear stress, we took the shear stress formula, right over here. Then we make derivative equal to 0. Then we figure out tan 2 phi formula. In terms of sin by cos, we get this formula. And we see from the tan 2 phi p formula and 2 phi s formula, we see that they are perpendicular to each other because they are slope actually. Multiplication is coming -1. Now, mathematically, we like to prove, we like to figure out the equation for tau max, tau minimum, and we like to see what is the value of sigma in that case. So, from the triangular equation, from here we make a triangle to figure out cos phi p, sin phi p. We did this one before. Actually, right over here, this will be phi s. By mistake, I put phi p over here. Okay. So this cos phi s equal to this one, sin phi s equal to this one. And these two value we put over here. We put over here, after simplification, we get this formula. Similarly, same condition we put over here, and simplification we see this term comes 0 and we have this. Okay. That's we got. So any question, if we solve a problem, then it will be very clear to you. So any question, anyone? Any question? Hello?
No, sir.
No question? Okay. Hopefully, if we solve a problem, then it will be easier for you that how we can apply those formula. Okay. So I solved a formula over here. Let's see. Now go back to our slide. Let's see in the slide what we have. Right over here, all the formula we summarize right over here. This is mother formula. This two, this not this two, this four. And shortcut formula to figure out the sigma max, sigma minimum. You can use directly this formula. And obviously there will be tau right over here. But say you using shortcut formula, then you can easily say what is the tau? Tau will be 0 without calculating, right? But if you use the mother formula, say you got sigma 1, sigma 2 by 2 phi p angle. But tau value you're not getting 0. So tau value you are getting -5 or -2. That means you are somewhere you are making mistake. Then you need to reset it. But if the result is matched together, then you know you are right. Similarly, this is the shortcut formula to figure out the value of tau max and tau minimum for 2 phi s angle, right? So this will be angle 2 phi s. So any angle you cut, there will be two values. one sigma, other one tau. So what is that sigma value? You have for this one, what will get? You get two angles, right? Say phi s and phi s, 1 and 2. So both case you get same sigma average, and tau will get one time plus, other time minus. Okay. Then for 2 phi p, what will get? For 2 phi p, you get sigma maximum value, say sigma 1, you get sigma minimum value. And what is the value of the tau? Both case, your tau value will be 0. But you can use the shortcut formula. If it is not coming matching with this one, that means it is something. Okay. Now we can solve a problem that will be easier. There is something else, which is later one. It's called Morse circle. And this method, we figure out the tau max, tau minimum, sigma 1, sigma 2, tan phi p. This method is called algebraic method because we figure out by mathematically. And other way we can figure out that is more easier. It's called Morse circle. You can draw a circle. If you draw a circle, what do you need? You need circle center. What is the center of the circle, right? Then you need what is the radius of the circle. Then you can draw the circle. And from that circle, we will figure out the value of tau max and tau minimum without applying this formula. Okay, that's easier. So we will discuss it later on. Now we will solve a problem. Okay. Let's see. Now sign convention, I put that if it is the algebraic method, then what sign you might use. Okay. This is sign convention for Morse circle. And for algebraic method, right over here, I put angle phi positive for anti-clockwise, tau positive for anti-clockwise, and sigma if tension positive, if compression is negative. And where you look, you have to look right over here. This tau try to rotating clockwise, anti-clockwise, so this tau positive, and sigma tension is positive. And for tau, you don't have to look over here, you don't look other three sides, just one side. And then you look for sigma. This one. Sigma is positive, is compression or tension. If it's tension, then positive. Compression, then negative. This is for Morse circle convention, and we'll discuss it later on. I think I solved this problem in the MathCAD file, and I feel it easily you can solve it. What will be value of from here? You see value of sigma x. Sigma x will be 90, right? 90. What will be sigma y? 30 positive. What will be the tau value? Our formula tau was opposite direction, but over here rotating clockwise. So right over here, tau equal to minus 40 degree. I'm sorry, 40 megapascal. So it's saying a plane stress element is subject to stresses as shown figure below. Find the principal and maximum shear stress and their direction by using Morse circle diagram. Show alignment of each element with respect to XY coordinate and find part A by algebraic method. So this is now part A. We are doing with algebraic method, and next time we will do graphical method. And we will teach you the talk about the Morse circle. Okay. Now let's solve it with the MathCAD. That's how we can solve it. Anyone has any question? No? Okay. Right now I am taking class with section A, right?
Yes, sir.
Do you have any class tomorrow at 1 o'clock? I feel if you are able to join in the class tomorrow, then we might don't have to take the extra class on on Saturday. That I'm saying. Okay, so if it's possible, if you join, you can join tomorrow. Okay. Otherwise, I have to take Saturday class. Somebody recommend at 10:30. I think 10:30 or might be 9 o'clock, 9:30. Okay, so we put it over here. I changed the question over here. Find the principal maximum shear stresses, their direction by algebraic method. That is put over here. Okay. Now, how we can solve it? Obviously, we need the formula, right? So this is our mother formula. I put it the yellow color. 1 and 2. This is for principal stress. Second equation for shear stress. And what is our shortcut formula? Right over here. Our shortcut formula. Okay. Now, we don't know the angle. Which angle will be principal stress and which angle will be shear stress. So this our two formula we need. Tan 2 phi equal to this one and tan 2 phi s equal to this one. Okay. Now, this is normally we don't write formula first. We write down formula later on, right? So at first, after you draw the, you say answer to the question number 2, then draw the figure. Then you say given sigma x equal to 9. So you look in the figure sigma x 9. What will be sigma y? 30 megapascal. So look over here, sigma y 30. You look this side and this side. Other side you don't have. So you got obviously has to be same. Otherwise, the answer the problem is not right. Then tau xy. When we derived the formula, this tau was rotating anti-clockwise. That's so positive. But over here, tau rotating clockwise. This 40. You have to look only in this side. So it's rotating clockwise. So this will be negative. So we put tau value is negative 40. Now, at first we figure out principal stress. Then we figure out the shear stress. So principal stress tan 2 phi p equal to, this is the formula. Okay. Actually, in that formula, I am not able to figure out directly. So what I did, tan 2 phi p will be equal to this one. So I just made 2 break. What I did at first, I figure out first at first this value. This value equal to how much? So minus 1.33. So what will get that time? I'll get tan 2 phi p equal to minus 1.33, right? Then you by calculator you figure out the phi, angle phi. So right over here, I put that angle. I got tan 2 phi p equal to 53.1 degree. That means tan minus 53.13 equal to this one. And if you with 53, if you add plus 180, it will give the same result. So I'll get two angles. Tan 2 phi equal to minus 53.13 and 2 phi equal to minus 53.13 plus 80 equal to 126.87. From here, I just figure out phi 1, half of this one, and phi 2, half of this. This is my phi 1, this is my, I'm sorry, this is phi 1, and this one, phi 2. And now, in the equation, and this angle, we put in the mother equation, over here and over here. But instead of, in the equation, we have 2 phi p. You can use put angle phi, but instead better if you put direct 2 phi p angle. One time you put minus 53, other time you put 126.87. So you put that angle in the equation. I say value of phi 1, phi 2 in equation 1. Okay. So after putting the first angle, phi 1, I'm getting 110. And second angle I put, I got 10 megapascal. Now this one I got for this angle, minus 26.57, then I got 110. When I put 63.43, or you can put direct 2 phi angle, then we got 10. and I put those angle in the phi equation, tau equation, and we got 0. Both cases you see. It obviously has to be 0. It's not coming 0, that means we are making mistake. So what is our result? 0.51 minus 1 is 6.57, sigma 1, 110, tau 1, 0. When you put the next angle, we get in sigma 2, 10 megapascal, and tau 2, 0. Okay. Now, you look in the problem. I add one more thing, that find the direction of the plane. What does it mean? Or orientation of the plane. Show the alignment of each element respect to xy coordinate. So in shear plane, in principal plane, we got the angle, and also we got the value, sigma 1, sigma 2. Now how you can draw the orientation over here? So let me draw orientation. At first, what we draw, our original element was just rectangular, right? With along x and y axis. You see right over here, like that, right? So x axis was horizontal. So this is my result right over here. So I'll draw the x axis first. So this is my x axis. And I can say over here, this is my x. Now I'll draw my angle. And what is the phi 1? You start the smallest one. Okay, it's better always try the smallest one, or maximum sigma 1. So you see phi minus 1 is 6.5. So which direction we have to move? Clockwise or anti-clockwise? Anti-clockwise was positive, but this is negative. So we have to go by along clockwise direction, opposite direction. So I make just a line. I'm saying this is angle is making 26.57 angle degree. And use your geometry tool, you will draw this angle. Now, in this angle, you have maximum, you got maximum normal space, right? What is the value? 110. Now you have to draw the rectangular. How you can draw? You will feel there is low line in the x-axis. Now you will draw a rectangular element with respect to your new axis. What is my new axis? Let me erase this one so it will be clear to understand. Okay, so this is my new axis, the angle. So I draw a rectangle. I'll make sure this will be center of the rectangle. I draw a rectangle. Make sure it is square. In the exam hall, you bring your scale and pencil, eraser, so easily can do that. Okay. So on this element is rotate, or this you cut it in this angle, then right over here will be sigma 1. So then you draw a line. You can say this is 110 megapascal. And obviously we got positive value, right? So this is your sigma 1, 100 megapascal. You write down the unit. And what will be the other side? Obviously, other side has to be same. The other side will be 110. You write down this 100 megapascal. So over here, you write down 110 megapascal. This one also equal to sigma 1. And obviously, you have to mention the unit. If you don't put unit, your mark will be deducted. Even your result is right, but still you have to put the unit. What is the next one? Next one, 100. Positive 100, right? So it will be tension. If you get a negative 100, then it will be compression. The arrow will be toward the body. So next, this one, at first you got the sigma 1. So obviously other two will be sigma 2. You don't have to look at it. Okay, directly you can put. So your sigma 2 will be 10. So this will be tension because it got this tension. Then you write down this is sigma 2 equal to 10 megapascal. With unit, then you write down sigma 2 equal to 10 megapascal over here. Okay, that one I make it right over here. And in the small letter I write down over here, this is a orientation of principal plane. And I mentioned the degree, mentioned the x-axis. Okay. Now, so this mass you did for principal plane. Now, which one left? For shear plane. We need to use the formula tan 2 phi s. So we use this formula tan 2 phi s. We got phi 1 equal to 18.4 degree, and tan 2 phi 108.4. You see 90 degree. If you use 2 phi value, you add 180, and only phi 1, then you use 90 degree. Okay, and automatically you use calculator, you can easily figure out. Now you put phi 1 in the mother equation, in the our tan equation. What is our shear stress formula? Shear stress formula is, your time is over, just bear with me 1 second. This will be the last problem. So we use this right over here, this formula. So if we put the first angle, we got minus 50 megapascal. If put second angle, we got 50 megapascal. You see, same value come with opposite side. We figure out the sigma 1, sigma 2 for both angles, automatically getting same value and coming equal to this one, 90 plus 60, or 90 at 30, 120 divided by 2. So it's coming 60. Now we need to make the, 1 second, sorry. I need to okay, now how we can draw it, the orientation of the element. I will draw it, but better to draw it over here. So at first you draw the x. Okay, in the other one, in on things I missed, right over here. That better to mention it. That shear stress I didn't show over here, right? But shear stress is 0. So if you want, you can show it like it don't matter because it's 0. So you don't need to worry about the direction. So just make sure head to head and tail to tail. Then you can say tau right over here equal to 0. You can say right over here tau equal to 0. Okay. So in the next, we figure out the shear stress. So we need to find the orientation of the element. So just look at the result. At first, you draw the x-axis. And our x-axis initially was horizontal. This is x-axis, our cutting plane, 18.443 degree, and positive. So you have to go anti-clockwise rotation. So this is our next line. This is the angle. Now we forget about this x-axis. This is our new x-axis. So with respect to this new axis, you have to draw the rectangular element, square element, and make sure that this is rectangular element. You need to make sure this line perpendicular to this line. Okay. Now, what will be the normal stress right over here? Equal to sigma average, right? 60 megapascal. So you draw the arrow. Let me pick up the other color. So this is 60 megapascal is the normal stress over here. On the other side, same 60 megapascal. Other two side, we got the same value for phi 1, phi 2, 60 megapascal, 60 megapascal. Now share. You fixed right over here, then you are fine. What is the angle over here? 18.43 degree. And what is the tau 1? Tau 1 was negative 50, right? So in our formula, if tau rotate anti-clockwise, that was positive. So right over here, tau will be then clockwise. So you just put arrow downward. You got this arrow. Obviously, bottom one will be face to face, and this will be tail to tail, and this will be head to head. Then you write down over here tau equal to 50 megapascal. I did over here tau equal to 50. Then you just mention this is the orientation of shear plane. Okay. Now I draw it more circle. You would need to, but I like to show you one thing, but or you can do it by yourself. Let me, I did it or not. Let me erase everything. If we use this formula, sigma x, sigma y, this formula, you will get the same value. If you're not getting the same value of this one, that means you did something else. So in the exam, what we can do, use the formula I mentioned in the MathCAD file. Then other side, you just do a rough calculation. It takes only 1 minute to make sure that your result is right. Okay. So we can stop it over here. Anyone has any question? Anyone? No?
No, sir.
Okay, we can stop it here. And